Hello everyone. Today we are going to discuss about cubes. So in the first classes of data structures, we discussed about abstract data types. Am I right? Now in abstract data types, what will happen? In abstract data types, the functionality, if I want to do some functionality, the user can know what is going on. That means if I want to insert, then I will insert them. So I want to delete, I can delete them. But what is the inner functionalities? We don't know. So those are abstract data types. So in those abstract data types, we have three types. One is the linked list, second one stack, the third one is queue. So in previous classes, we already discussed about the stacks and linked list. Now the final topic of abstract data types, that is queues. Now we are going to discuss about queues. See, in linked list, the operations I can do anywhere. I can do the operation at the starting, at the ending, or I can do in the middle of the linked list also. But in stack, whatever the operations I'm doing, that is insertion and deletion, I can do at the top only. But in queues, I can do the operations in two ways. The first, I can insert the value at the top. I can delete the value at the insertion at the top, deletion at the bottom. So whatever the values I'm inserting first, those will be moved to the bottom. So I'm deleting the bottom value. That means whatever the value I'm inserting at the first, that value I'm going to delete. Now I can say this process is a FIFO, first in first. Unlike stack, what happens? Whatever the element inserting last, that will be deleted. That's why I call it as a LIFO. Last in first. Here I can say it is a FIFO, first in first. Now let's consider an example. Let's assume you are doing a shopping. Alright, whether big bazaar or a bank factory, anything. After completion of your shopping, what will happen? You have to go to the building queue. Alright, so you came now. Now what I have to do? I have to join at the end of the queue. Now here the deletion means whoever the person here, that bill will be clear. When the bill is clear, these persons will move out of the, that means deletion. Alright. So if you see the process, whoever coming in at the first in the queue, those operations will be done first. That means those persons will be deleted first. So this is the general example. If you consider it in softwares, so let's assume you are booking a ticket in bus. So in the UI what you will do, you will select a seats and then you will do the purchase. After completion of successful transaction, you will get the you will reserve the seats. But if the two persons are doing the work at the same time, then what will happen? Whoever the first person reserving that seats, whoever the first person reserving the seats, those seats will be allotted to the first person, not the second person. Am I right? The first person is booked the seats first. So whoever done the first process, those will be treated as first. So that is one of the example for queues. So a simple example is, let's consider we are in a queue for you can say it is in toll gate also. In toll gate also, the whatever the cars and buses comes at first, those toll will be collected first, right? So that is queues. Now let's come to the functionalities of queues. See, in stack we have six functionalities: insertion, deletion, and peak size, empty or not is. So those are essentials and non-essentials. What is essential and what is non-essential? If I want to create a queue, I need to do some operations exactly. Must and should I have to do the operations if I want to create a queue. Those are insertion and deletion. These are not necessary. Right? Those are not necessary. If I can insert a value, if I can delete a value, then I can do the operations on queue. So these two are essentials. These two are not essential. These are properties of queue. These are operations of queue. These are actual operations. Am I right? Now in stack here, I will say push. Here I will say pop. Pop is for deletion. Push is for insertion. In queue, NQ is for inserting. DQ is for deletion. NQ insertion, DQ deletion. So these all functionalities same as P for last to know the last element, size to know the size of the queue, and P is empty. We define the queue is empty or not. If no elements are available, it will produce a Boolean value. What is a Boolean value? Either 0 or 1. If it produces 1, then it is empty. If any element available in the queue, then it will produce the 0, that means false. Some elements are available. So useful also, it is also a Boolean operation. If all the elements are filled in the queue, then it will produce a true, that is 1. If any one element is available for insertion, one place is available for insertion, then here it will produce a false, that is 0. So I can insert a value. Am I right? So is this empty function? This functionality I can use at the deletion. This full functionality I will use in insertion. Alright. If I want to insert a value, I need a space. So I will check whether it is full or not. If it is not full, I will insert. If I want to delete, I need one element, at least one element it should be available in the queue. So I will check whether it is empty or not. If it is not empty, then only I can delete the element. Now let's consider it is a structure. As you know, so this queue have 5 elements. 5 elements, 1 to 5. But according to computers programming, the elements addressing starts from 0. So the first position represented with 0, second position represented with 1, third position represented with 0. So say the fifth position represented with 0. Alright. So I can consider these addresses for operation, but because I'm using the programming. So I have to follow this programming addresses, not the positions. So these are the operations I have to perform. So first I will do the insertion. So here I want to insert a value. So first I want to read a value, right? So here in the NQ I'm forwarding the value. So now I want to insert. See here what will happen here? The test the value first start from the top. So it will check here. If the fourth address field is available or not. Okay, it is available. Then it goes to the third. Is it available or not? Yes. 2 available or not? Next 1 available or not? 0 available or not? Yes, it is available. Next 0 below no address. So it will store here. So if I want to store another element, then what will happen? So now I want to insert 20. Now what will happen? Again the same process. First it starts from 4. Is 4 available? Yes. Next 3. Is 3 available? Yes. Is 2 available? Yes. Is 1 available? Yes. Is 0 available? No. Now I will increment to the here and I will insert here. I will insert. So it will check from top to bottom. Whenever the where I want to, it will find where I want to insert. Then it will find the position and it will insert. It will search from top to bottom. At bottom, where if I want to insert here, next again, if I want to level, it will check from 4 to 0. Again, I'm inserting a value 28. Again, I'm inserting a value 28. The same process. So now also if I want to insert, it will check 4. It will check 4. Is 4 available? Yes. Next, it will downwards. It will go downwards. Now, is 3 available? No. So then the cursor will be fixed to the 4. Will be fixed to the 4 because the 3 is not available. So I have to insert it. I have to insert it. Alright. Now, if I want to insert the elements, the operations will be done like this. So first I inserted 10. Next I inserted 11, 28, 12. So whatever the elements I'm inserting at the top of the queue. Now I already done the deletion insertions. Now I have to do deletion. Now is check if I do the easeful function right now. If I perform easeful function, now it will produce a because all the elements are filled. Am I right? All the elements are filled. So now it will produce a true statement. It says it is full. Now you cannot do the insertion operations. Now I will do the deletion operations. That is called DQ. As we discussed, DQ is done at the bottom. Am I right? So what is the bottom value available? 0. If I want to delete, this bottom value will be deleted. This bottom value will be deleted. Now, whatever the bottom value, it is deleted. Am I right? Now it goes to the next level. It will increment to the next. So 0 is increasing to 1. Right? 0 went to 1. Now, if again I want to delete the element, then now the cursor is where is the cursor? Cursor is at 1. So 1 will be deleted. 1 will be deleted. That one means at the 1 we have 20. Am I right? At the 1 we have 20. So 20 will be deleted. Now again if I want to do the operations, now cursor at 2. So 11 will be deleted. 11 will be deleted. So by insertion, here it will be increased. While deletion also it will be increased. Am I right? So how this will be happen in the programming? Let's see. Now we have already discussed insertion and deletion. So we have to implement through programming. Am I right? So like as stats in Q, we don't have any special data. So for this purpose, for implementing queues in C programming or any programming, I'm using arrays and linked list for implementing queues. Where I will use arrays and where I will use linked list. Arrays, if I have fixed size of elements and the space at a time, at a single space, then I will use arrays. If I don't have a space or that much space at one place, or I don't have a fixed size, then I will go for the linked list. Alright? Now let's consider class. See, first ID is created with 60 students. The first section is created with 60 students. Alright? Now, if I want to sit in the classroom, so I have 60 seats. I have to choose the 60 seats classroom. Alright? I have to choose 60 seats classroom at one place. So I have the 60 members in one place. I want to insert the elements only 60. If I have an operation like that, I will use arrays. For suppose, if I don't have an opportunity to sit 60 students at a time, 60 students or at a same place, then what I have to do? I have to do the equals. Right now, we are doing the classes in virtual. So in virtual, what is happening? The average students is sitting in the different places. In previous classes, we are sitting in the same class. So I can say that is an array. But here, we are sitting in your own places. But I am connecting with some addressing. Alright? With some addressing or with Zoom or some application. So the positions are different. But all are connecting in the same manner or same as a array, or same value. So for this purpose, for this type of applications, I will use linked list. Now, first I will implement arrays. Arrays. So as you know, arrays has three functionalities. In general, arrays has three functionalities. What are those? The first, I will create an array. Next, I will initialize the values. That means I am giving the or inserting the values into a array. Next, I will access the array values. So these three operations I have to do in arrays. Beside of these three operations, if I want to convert this array into a queue, I need these three variables. So I want to convert arrays into a queues with all three necessary operations in the array. I have to use these three variables also. The first variable is friend, second variable is rare, third is max. Max, as you know in the stack also, max represents the size of the queue. So what are the elements max possible in the queue that will be displayed by max. So as we previously discussed, I want to insert the 60 students in a empty class. So now my max value is 60. Am I right? Now, red, it represents where I want to insert the element. So it represents the topmost element. It represents topmost element. So red, if I want to insert the element, I will see the rare element. If rare is available, then I will insert. The front is used for deletion. So deletion I am doing at the starting. So the front represents the starting element. So rare represents ending, front represents starting, max represents size of the curve. Right? Now let's check the examples. Now from now onwards, in previous slides, what I have done here, I declared a position, next address, next value. Right? I used the three columns, but now onwards I'm using only two columns. Why? Because for removing the ambiguity. So if I want to delete it, say one means you have ambiguity like to consider the position or address. So for removing the ambiguity, now onwards I'm going to use only two columns. That is, one is address, second one is value. So if I have a view like this, what will be the three variables? What are the variables I'm using? One is max, second is rare, third is frame. Now max, size of the cube. Now what is the size? So max will be 5. So size is 5. So max will be 5. Now the rare will be where I have to insert. So already these 5 elements up to 4 I have already inserted. Next where I have to insert? I have to insert after 4. I have to insert after 4. So that means that where is 5. Now where I have to delete? The first element is at 0. The first element is at 0. So I have to delete at 0. So print will be 0, rare at 5, max at 5. So if the Q is like this, Q values are like this, then what happens is rare is 5. If I want to insert the element, I have to insert at the fifth address. But Q has the size of 5. So that means 0 to 4 only available. Is fifth available? No. So if rare is like this, then I cannot insert a value in a Q. So what is the condition here? If rare equals to max, then I will say the Q is, see, if you consider the other examples in the internet, here rare will become as 4 because they, here they are representing the last element of the cube, last element of the cube. So here last element is at the 4. So they will consider the rare as 4. If I want to insert the value again, then they will increment the rare, they will insert the value. But if I do like this, I insert the value in the array, then after. So both are the same. There is no difference. But only the applying functionality is different. If I use the rare like this, I will insert, then increment. If I use rare at the top of the element, then I will insert after that I will increment. Alright? No. So in previous slide, we have 5 elements. In these 5 elements, if I delete 2 values, that means if I delete 0, if I delete next to the 1 position, and that means 10 and 20, then the cursor has to move to the 2. That means the first front is 0. After deletion, it will increase to the 1. Next, it will increase to the, alright? Next, it will increase to the 2. Now, what are the values? So, front will become as 2 and rare become as 5, max is 5. Whatever the operations you are doing, the rare maximum value will not be changed. Why? Because the size of the queue is fixed in arrays, the size of the queue is fixed. So whatever the operations you are doing, whether you are inserting or deleting, the maximum value will not be changed. What are the values will be changed? The rare element and friend element. The friend is 2, the rare is 5. So again, if I deleted 2 elements, then here, what will happen? Rare is 5 and the friend is 4. Right? Friend is 4, max is 5. Alright? So again, if I deleted the element, then what will happen? Both will be deleted, rare will be incremented. So rare equals to 5, equals to 5, max equals to 5. Now, can I delete any element? No. So how to check whether the elements are available or not? If the condition is like this, then the condition is friend equals to rare or friend equals to none. Friend equals to rare or friend equals to none. Right? Initially friend is none. Initially friend will be null. After insertion it will be incremented. So I can say friend is null or friend equals to rare. The both conditions I can say the queue is empty. Now let's conclude this lecture today. Now what we discussed in this lecture, we discussed the basics of queue. What is the basics? The queue operations are done in two ways: insertion at the top, deletion at the bottom. Right. Now operations can be queue. I can call it as a first in, first out. So operations of queue are six. Insertion I can call NQ, deletion DQ, and the non-exception operations are four. What are those? One is full, is empty, and peak and size. These four are non-exception. Next, we discussed about the implementation of code. How we are implementing? We are implementing by using arrays and by using linked list. So, we discussed the arrays basics. What is the basics? In arrays, we have three functionalities. What are those? I need to create, I need to assign a value, I need to access the values. And I have to implement these arrays to queue. For implementation, then extra what I have added, instead of using these three operations, what I have used three. I have used three variables. What are those? One is p, so one is friend, second one is rare, the third one is max. Maximum represent size of the queue. Rare represents where the element should be inserted. Friend represents where the element should be deleted. In next class, we are going to discuss how we are implemented here in a programming. Now, we implemented arrays for queue in a theoretical manner. Now, I will convert this complete process into a programming. So, in next class, I will do the operations of arrays in a C